little bit in our functions chapter. So we're going to have a look at some more modulus functions, focusing on the higher level functions now, so quadratics, cubics, and the more complex functions. Specifically, we're going to be using y equals f of the modulus x. Okay, so in one we're doing modulus of the whole. Always want you to start this is always to start with sketching y equals f of x. So we're going to use x minus 3x plus 1, and I've sketched that for you. Okay, so we've got roots at 3 and minus 1, and we've got a y-intercept at minus 3. Now, when we do the modulus of f of x, the modulus of the whole function, now we should know the modulus means we can't have negative solutions. Any negative solutions become positive. So what this means is I am looking for any point on the graph where I have a negative answer. So I'm looking for anywhere that is below. Okay, so that means I'm looking at that gap between 3 and minus 1. And all I'm going to do is anything that's below the x-axis, I'm going to reflect upwards. Okay, obviously I'm going to have to think about what happens to my y-intercept. That's going to get reflected upwards as well, and we should look something like that. Okay, so there will be nothing below the x-axis, and it just gets reflected upwards. The second one, so y equals f of modulus x. Now that just means I am making my input positive. So the first side is going to stay the same. Okay, the positive side of my graph will stay the same. Okay, but then when I get to the negative inputs, they're going to flip instead and become positive. Okay, so what ends up happening is anything on the anything on the right hand side of the graph, thing on the left hand side gets taken away, and the right hand side is reflected. Okay, right side is reflected over. So positive will stay the same, that then gets reflected. Okay, obviously you've got to think about what your other root would now be, and that's just going to be the reflection of 3, so that will become minus 3. Okay, so modulus of the full function, anything below the axis gets reflected up. Modulus of just the inputs, the right hand side gets reflected to the left hand side. Right, let's just have a look at another one. So sketched here, f of x equals x squared plus x minus 2. Okay, obviously the first thing you're going to want is to find all of your intersections of the axis. So if this wasn't on nice square grid where you could tell, you're also going to need to find the roots. So we'll factorise to find the roots. So we can have x plus 2, x minus 1. So we can have roots at minus 2 and 1, which are obviously there. And my y-intercept at minus 2. Perfect. Right, first one I want to sketch is the modulus of f of x. So that one, anything below the axis gets reflected up. So my intercept that was minus 2 will now become 2. And all that's going to happen is this is going to get reflected up and over, and we're going to look like that instead. Okay, just put in the whole graph, come all the way down, and we just get reflected over. Okay, so we're going to look like that. All y values are made positive, so we reflect above the x-axis. Now the next one, okay, f of modulus x, that's where we're going to reflect the right hand side onto the left hand side. Negative inputs, okay, give us the answers from the positive side. So all that's going to happen is I reflect the x side over. So my root here that was 1 is also reflected over to give me minus 1 instead. Okay, obviously my intercept will not change. Okay, 2 parts. If it's the modulus of the whole function, you reflect from bottom up. If it's modulus of the input, you reflect right to left. Right, have a pause of the video for me, have a go at those, and then we will have a quick look. Okay, so have a pause, and then we will have a look. Okay, right, let's have a look then. So, this time you're not actually given the equation, okay, but we are given points of intersection, okay, and we're asked to draw modulus of f of x and f of modulus x, okay, and it's really important we put the coordinates on as well. So, the modulus of the whole function, anything below the x-axis gets reflected up. So the only bit that's below the x-axis is this piece in here. So all that's going to happen is that piece is going to get reflected up above the x-axis. So all I'm going to do is take that piece there, and that's just going to get reflected up instead. Okay, everything else will stay exactly the same and will just get reflected up and over. Okay. The second part, y equals f modulus x, that's where anything on the right hand side gets reflected over. So this time, if I just get rid of the previous part, this time the only bit that I'm initially interested in is this first part of the line here. Because as soon as I go over my x-axis, okay, it just gets reflected over. So all I'm going to do is reflect this line over this side. Everything else on the left will just disappear. Okay, I'm no longer interested in it. None of my intersection points have changed. I'm no longer going to get a y-intercept for the second graph because it doesn't get any, a root for the second part because it doesn't get anywhere near the x-axis. Okay, and that's what we're looking at. Shouldn't be anything too difficult, guys, as long as we sketch the original function accurately and effectively and put all the intersections on. It's nice and simple. Two parts to remember. Modulus of the whole function, you can't have a negative solution, so everything below the x-axis gets reflected up. If you're doing the modulus of just the input, draw the right hand side, reflect it over onto the left hand side. Right, check back onto share my homework for me and have a go at the questions mentioned for exercise 2E, please.